Thank you. That was a really long list of things to a lead developer has to do, doesn't it? I'm a little bit disappointed now that this isn't a talk about baking. I kind of feel like I missed an opportunity there. However, I'm going to be talking about a technical subject. We've talked quite a lot about the leadership side of lead development and running teams, and now we're going to talk a little bit about more technical or strategy type things. And my area of expertise is APIs, HTTP APIs. I do a lot of APIs. I integrate with a lot of APIs, and I write APIs. I write legacy stuff. I integrate with legacy APIs, and they can be problematic. They can be difficult to work with. And I would like going forward that when I'm working with your APIs in 10 years' time, that I'm much happier with them than the APIs I'm dealing with today, because they are horrible. So what we're going to talk about now is 5 features of a good API, from my point of view, things I would like you to get right to make all the client developers that have to deal with an HTTP API that you have built much, much better. There we go. So I'm going to be talking about RESTful APIs, HTTP APIs, as I said. The key thing that you need to think about when it comes to your API is that it must be fit for purpose. It has to do its job. More than anything else, it has to make sense for your business. It has to make sense for the people who are integrating with it. Practically, nothing else matters. If it does not fit for purpose, it will not get used. There's no point in creating a RESTful API if an RPC-based one, or a GraphQL-based one, or a SOAP service would be a better solution. Don't dive headlong into the new hotness if it is the wrong fit for your particular problem. These are the 5 categories that we're going to be talking about today. Good API has got malleability. It has correctness. It will have good error handling. It will have good documentation. And it will have good security. So we're going to look at each of those in turn. Start with malleability. I love the word malleability. It's such a cool word. It just means flexibility. Good API is flexible. And we can look at that in 2 different ways. We can look at internally, how we've built our actual API itself, our application. And we can also look at it in terms of the client and how the client is using our API and how flexible we can be for them. So firstly, looking at the internal application, an API is a full application in and of itself. So it should be built and structured and well architected. Fundamentally, that means you should decouple your representation from your business logic and from your database. Your database, your entities, your application logic, they are all the key parts of your application. They're the key parts of your architecture. And I don't want to see them exposed directly in your representation. When we build an HTML web form, or when we build an iPhone app, we do not use the field names on our database as the labels on the form. For a reason. It makes no sense to the client. The same thing is true for an API. We don't have to expose the database column names directly in our representation in the JSON that goes to our clients. We can do better than this. If we decouple, we make things more flexible. The change, the rate of change, the things we want to change will be different in our application logic and in our representation. If you have coupled the 2 together, you have ended up with a very brittle situation, and it will be very difficult to change things, and so you will be resistant to change, and that will impact how flexible and how fast you can move your API and keep it working for your clients. It's really important to decouple. On the other side of the fence, we have how do our clients talk to our API? We would like this to be flexible as well. We would prefer it if our clients don't have to hard code every single endpoint in order to operate with our API. Because if they hard code everything, we can't change it. And there's this magic word called HYPERMEDIA, which is another one of those complicated words that we say to make it sound like we're really cool in this industry, which basically means a link. It's not particularly complicated. We do it all the time on the web. Hypermedia in APIs means that we put links inside our API payloads. That's all. And it gives us a number of advantages. It means that we can create an explorable API. I don't know about you, but when I get a new API to work with, the first thing I do is hit it up in something like curl or Postman, and I explore it. I try to see how it works. I don't go and read the documentation until I have to. So if my API is more explorable, then my new developers, the people that are thinking about using my API, stand more chance of understanding what's going on, and that's really helpful. I can rename endpoints at will, and all my clients will not break if they have full URLs. And that is, again, a form of decoupling. Rehoming those endpoints onto different servers can be really powerful, because we can do that if it's not hard-coded in the API. As I say, they are just links. So here's an example of a payload in the HAL format, application HAL JSON media type. There's XML versions as well. You just have links. Here we have an order, and if I want to expose the customer for this order to my client, I provide the full URL for them to be able to retrieve the customer details. My shipping note might be a PDF. It's on a different server. It's on the CDN. It's quite easy for me to provide a fully qualified link so my clients don't need to hard code. The less hard coding we have, the more decoupling we have, the longer lived our API will be. Good APIs are correct. The nitty-gritty matters. HTTP in particular is an extremely well-specified protocol. It's been around for a while. We've only just got to version 2. Version 1.1 was 18 years long. That's quite a long while. It's really well worth reading the specifications for HTTP. There are 2 RFCs that you need to read, RFC 7230 and 7231. They're not particularly long. They are remarkably well written, and it is in your interest to read them, to understand how the web works. URIs, the request-response format, how intermediaries work. There's this common misconception that when someone's got an iPhone app and they talk to your server, that it's a direct connection. It isn't. There are proxies in the way. There are gateways, there are tunnels. There are other parts of the internet between that phone and your server. HTTP specifications describe how those intermediaries work, what they can cache, what they can't cache, what will happen when there's disconnections and things like that. It's worth understanding and being aware of this. HTTP verbs are really, really helpful. They were invented for a reason. They create a more semantic description for your API. And there's something called idempotency, which is really helpful if you don't live in Silicon Valley, where the networks are perfect. The rest of us don't live in a perfect network world. In particular, my train from Worcester to London goes down a branch line. It's a single-track line. We stop at the station to wait for the next train to come along. As you can imagine, the mobile networks are maybe not as good as they are here in London. It's really common to have disconnections. Idempotency is all about whether you can repeat a command or a message into the server and whether something will change as a result. So an idempotent message, I can send the same message multiple times to my server, and after the first one, nothing will change. This makes it very, very safe for usage on a less well-connected network. Understand what the verbs are for. You're going to use the get method for retrieving data. You're going to use put or patch or post for updating data and changing data. The intermediaries will behave better as well. They will know how to interpret the request and handle it properly if you're aware of this, and implement these methods in your APIs. Status codes. I can't tell you the amount of times that I get the wrong status code back, and it is amazingly frustrating. They are a very easy way to classify the type of response we've got back from the server as a client. There's only five different groups, And within each group, then we have specifics. Get the status code right, because then the client knows what to do. Do not send a 200 OK with an error message. This is wrong. It happens so frequently, it is unbelievable. Do not make those sort of mistakes with your code. We have these specifications, we have this ability to do it right. If you send a 400 error, or 1 in the 400 class, the client knows that it can attempt to do it again. If you send a 500 class error, the client knows there's nothing that it can do. You're telling it important information in a very easy way to send it. Media types are the way we communicate and understand how to interpret data between two computers when we use an HTTP. We use this all the time for the web. The most popular media type in the world is text HTML. It's what we run the web on. We can use the media type to provide information to our clients on how to interpret the data we are sending them. I've already alluded to application HAL JSON. That's a more specialized JSON format that the client can then interpret and can expect certain keys, will know how to interpret this particular format of message and be confident that it knows what to do with it. If we're using standardized media types, then we can have client libraries written for them already, which means there's less work for our client developers to do, and they are more likely to want to use our APIs. And we can provide more semantic information to them to help them understand and use our API well. Similarly, the content type header coming to us tells us how to interpret the data from the client. The client is telling us this is the format of our data. We should be able to interpret it quite easily. Good APIs have really, really good errors. Error handling is very, very important. I can't emphasize this one enough. If you want me to use your API, have great error handling. It's the part of the API that the humans have to deal with. It's very, very important that you understand that when things go wrong, the client developer is more stressed. The client who's trying to integrate with your API is not having a good day. Make their life easier. Error representations are first-class citizens in your API. Treat them with the same respect that you did creating that entity, you did creating that collection. That means that you put the correct content type on it. You don't send it as HTML because that's what Tomcat does by default, for instance. Hypothetically speaking, of course. Correct status codes make a big difference. Headers. Set the cause header, as I was reminded yesterday. In an error situation, the JavaScript still needs to deal with it. Don't shut them out and make their life harder. Provide codes that the computers can read and messages that the humans can read. Codes are very good for computers. Humans hate them. They're very, very hard to understand, and you're already in a stressful situation. If you're sending JSON, pretty print the JSON. It's such a minor thing. But guess who reads the error messages and the error statuses? It's the humans again. And it's so much easier if we don't have to format it through JQ ourselves. We can just see the error. A successful message, don't bother. Nobody ever looks at successful messages other than computers. So we don't have to care about formatting those ones. But the error messages, the humans are going to have to read them. Make it as easy as you possibly can. Format it in a predictable way, and it turns out there's a standard for that. RFC 7807 is the HTTP problem standard. If you don't have a formalized way to send an error response back from your client to your clients, use this one. Other people have thought about it, it's good. It provides all the information that a client will need with standardized field names, which means that as a client developer, I can use a library. I just install a library and I can decode your error messages and I can deal with them correctly because I've got the right semantic information. very, very helpful to have standardized systems because we can write libraries for them. Don't have to keep re-rolling the same code ourselves. HTTP problem is a very nice standard. I like it a lot. The key fields in this particular representation are type and instance. Do you notice that they have URLs in them? That's important because there's not enough information here to solve the problem. So the standard specifies that you provide links to documentation about the problem to help your clients solve it for themselves. Every time you write great error messages, you reduce the number of support tickets you get. That has got to be a big win. Really, anytime people don't need to contact me, this is a win. Type provides a place where you can tell the client, go here to find out what you did wrong and what I'm expecting you to do. Which leads me very nicely onto a great API has documentation. It is extremely well documented. It's quite easy to explore an API and get a feeling for how it works. It's much harder to use an API well without good documentation. If I've got two APIs that I can integrate against, and my client is letting me pick which one, I will invariably choose the one with better documentation. Because the one with better documentation shows to me that that team cares. That team is looking out and thinking about their API. So they are the people that I want to be integrating against. And I know how to do it because they've told me. And that makes life so much easier. So when it comes to documentation, the first thing we need to do is find the documentation. That can be a challenge. You go to this website for the company, particularly payment gateways. I don't know what it is about banking people, but payment gateways in particular, they've got 6 different products. They've all got basically the same name except for one word difference. You have to work out which particular set of docs represents the one you're trying to integrate against. Quite complicated at times. Very frustrating if you get the wrong one as well. There's another standard. It turns out that the people who write the internet like writing standards. RFC 6906 is called the Profile Link Standard, and it is simply a system that says, put the documentation in a header so that people can find it. The profile, the description of this thing. So it's a simple header link, or you can put it in the body using HAL or something like that. Point at your docs. That's all you have to do. So I can hit your endpoint, and I can know where the docs are. Bonus points if you make that link specific to the particular representation that you are rendering, because then I get straight into the correct technical documentations for all those fields. It makes life so much easier. There's 2 types of documentation that you need to write. If we go back to that estimation talk earlier, this is a section that nobody has ever estimated, and it wasn't even a story. It's funny how that happens. It's that other 80%. Write tutorials to show how to use your API. These are the way that you help your integrators solve their problems. You've already worked out a number of use cases for your API, else you wouldn't have written it. Your integrators, the people who are using your API, have a number of problems they want to solve. They have a number of business cases that they need to achieve. You, as the API developers, have a number of goals as well. You would like your integrators to use your API in the best way possible. The only way to do that is to tell them. Write tutorials to do that. If you're going to do it right, you're going to provide some code. It is likely that you have a preferred language. I don't know which one. Maybe it's JavaScript, maybe it's Go, whatever it might be. Provide your tutorials in as many languages as you can possibly do, and always provide at least one example in a non-language, like a curl example, or simple HTTP request and response description. Because if you haven't covered the particular language that a given integrator is using, everyone can read curl, and everyone can run curl. If you can't run or use curl, then learn. It's most far one of the best things you can do as an API person. Learn how to use curl. Or Postman. Postman's cool. Reference material is where you write down all the details of every single property that exists in every single representation that you supply to a client. It is extremely tedious to write. I hate you if you don't. There's this field in the representation, and it's not in the table, that tells me all the fields of your representation. What am I supposed to do with it? You must provide the information. You must tell me what the name is, what it does, and what its constraints are. Right, if it's a postcode field, please tell me that it's only going to be 6 characters long or 8 characters long. If it's a telephone field, it would be really nice to know whether I'm allowed the plus sign or not without having to experiment. The point of the reference documentation is to make it crystal clear how to understand every single field inside that API. Your API integrators will thank you for it, and they will tell your friends. They will tell their friends, sorry. When they tell their friends, you know what happens then? You get referrals. Referrals means more people use your API and your boss gives you a pay rise. This is how this works. It's really important to make good documentation that people can use because it's one of the key drivers of word-of-mouth recommendations. Lastly, I'm going to quickly talk about security. I'm going to take it as read that you are not going to release an API in 2017 that is not secured using TLS. Do not put your hand up if you're not doing that, because you'll only embarrass yourself. In this day and age, you must be using TLS, SSL. It's nonsensical not to. You also need to identify each client application that is integrating with your API, and you need to know about each user, because this gives you some flexibility to know what's going on. There are a subset of APIs where you don't need this. They are very, very small, and relatively speaking, you don't need to care about those. Always, always understand who is hitting your API. It gives you a certain amount of control. If you know which client's hitting your API, then you can turn them off if they go rogue, if they start using up too much resources, if they start behaving like bad actors. You can start doing something about it. If you know which users are hitting your application, then obviously you can provide the right data to them. It's amazing how many people want to roll their own authentication system. I don't know what it is about developers and not invented here, but come on. This problem has been solved. There are a number of different standards out there. As you can tell from this slide, I obviously prefer OAuth 2. My main recommendation is pick a standard. Use a standard. OAuth 2 is a really, really good standard for this because it has lots of different use cases. So it is highly likely that whatever use case you have for authentication and identification of users or applications, OAuth 2 will have a use case for that, a grant type, they call it. The other nice thing, again, about using a standard is that there are client libraries written for it. So you have just reduced the amount of work to integrate against your API. That is a good thing. Do that. Make it easy for people to integrate against your API. Nobody likes writing login code. It's not particularly interesting. If I can just drop a library in and I can authenticate against your API, then you've passed the first hurdle, a good hurdle. The other key thing to think about is that it's highly likely that your users have a relationship with you and not necessarily the same relationship with the third-party client application. So the classic example is something like Twitter. If I've got Tweetbot on my phone, my data is with Twitter, how much do I trust Tweetbot with that data and with my password? The advantage of something like OAuth is that we can decouple that relationship so that myself as a user, I can authenticate with Twitter directly and give tokens and less permanent authentication mechanisms to the third-party applications like Tweetbot so that I can control as a user how long they have access to my data. That's a really powerful feature to be able to give to your users. And again, in this day and age, in 2017, more control over data is becoming a feature of our world that we need to be aware of. Rate limit. So I talk about security in terms of authentication and SSL and stuff like that. There's also whether your servers stay up. Think about how much usage any given application or any given client is using of your data and whether they're paying for that, whether they're using up all your resources unfairly. And the way to handle that is with rate limiting. It's a pain to retrofit, so build it in at the beginning. It doesn't take too long to build it in and put in massive, massive limits, so you don't have to worry about it at the beginning. But when you start getting traction on your API and you can't grow your resources and your servers quickly enough, then it can be very, very helpful to be able to control how frequently any given client or any given application and user can hit your API. That's it. That's what I want to tell you about APIs today. So when you are building APIs for integration with other people, think about how you're building them. Think about how malleable they are. Ensure that you are not tightly coupling your internal application design to your external view that you are providing to your clients. Ensure that you are correct. The details do matter. Make sure you get the details correct. HTTP is a good standard. It is well specified. Understand it and follow it. Ensure that you have great error handling. Do not send me nonsense error messages. Send me good error messages that I can understand and I can act upon to solve the problem. Document your API. It's the most important thing you can do to get word-of-mouth recommendations. And finally, never ever forget about security. Thank you very much.